Hello guys. Are you bored in lockdown so much? So let's have some fun. Let's learn something new. Do you ever heard about circular linked list? Circular linked list is a linked list where all nodes are connected to form a circle. There is no null at the end. It can be a singly circular linked list or doubly circular linked list. In singly circular linked list, the next pointer of the last node points to the first node. In doubly circular linked list, the next pointer of the last node points to the first node and the previous pointer of the first node points to the last node, making the circular in both directions. Here you can see. First figure describes singly circular linked list, whereas second figure describes doubly circular linked list. In this video, we are going to discuss the operations supported by the singly circular linked list. Let's discuss insertion operation. A node can be added in following ways. Insertion in an empty list. Insertion at the beginning of the list. Insertion at the end of the list. Insertion in between the nodes. Insertion in an empty list. Initially, when the list is empty, last pointer will be null. After inserting a node T, D becomes the last node, so pointer last points to node T and node D is first and last node, so D is pointing to itself. Insertion at the beginning of the list. To insert a node at the beginning of the list, follow these steps. Create a node, say T. Make T next is equal to last next. Then last next is equal to T. After insertion, the list will look like this. Insertion at the end of the list. To insert a node at the end of the list, follow these steps. Create a node, say T. Make T next is equal to last next. Last next is equal to T. Last is equal to T. After insertion, the list will look like this. Insertion in between the nodes. To insert a node in between the nodes of the list, follow these steps. Create a node, say T. Search the node after which T needs to be inserted, say that node be P. Make T next is equal to P next. P next is equal to T. After searching and insertion, the list will look like these. Let's discuss the deletion operation. A node can be deleted in following ways. First position, last position, at any given position. Deletion at first position. Take two pointers, current and previous, and traverse the list. Keep the pointer current fixed pointing to the first node and move previous until it reaches the last node. Once the pointer previous reaches the last node, do the following. Previous next is equal to current next. Head is equal to previous next. This can be shown in the following way. Deletion at last position. Take two pointers, current and previous, and traverse the list. Move both pointers such that next to previous is always pointing to current. Keep moving the pointers, current and previous, until current reaches the last node and previous is at second last node. Once the pointer current reaches the last node, do the following. Previous next is equal to current next. Head is equal to previous next. This can be shown in the following way. Deletion at given position. First, find the length of the list. That is, the number of nodes in the list. Take two pointers, previous and current, to traverse the list, such that previous is one position behind the current node. Take a variable count initialized to 0 to keep track of the number of nodes traversed. Traverse the list until the given index is reached. Once the given index is reached, do previous next is equal to current next. This can be shown in following way. Traversing and circular singly linked list. Traversing and circular singly linked list can be done through a loop. Initialize the temporary pointer variable temp to head pointer and run the while loop until the next pointer of temp becomes head. Let's discuss the algorithm. Set PTR is equal to head. If PTR is equal to null, write empty list. Go to step 7, end of if. Repeat step 4 and 5 until PTR next is not equal to head. Print PTR data. PTR is equal to PTR next. Here loop ends. Print PTR data. Exit. Thus, we can traverse the circular singly linked list using this algorithm. Hope you've enjoyed watching this video. Thank you.